Hello, everybody. Welcome to another episode of Visual Studio Toolbox Live. I'm your host, Leslie Richardson, and today I'm really excited because we're going to be talking about machine learning and how you can use ML.net to improve your overall ML experience in Visual Studio. So joining me today to talk about that is Bree and Louise. And yeah, welcome, y'all.
Thanks for having us.
Thanks for being here. So before we dive in, would you like to tell us a little bit more about yourselves and what you do?
Yeah, I guess I'll go first because I'm up top here. So I'm Bree. I work on the .NET team, and I am the PM for ML.net, which we'll teach you all about in a little bit. Oh, that was pretty much it, but short intro. And I'll hand it off to Louise.
Yeah, mine will be short too. So I'm Luis. I work on docs for ML.net, .NET for Spark, and for Azure Machine Learning.
Awesome. So good stuff. So ML, that's just a huge buzzword from the get-go, right? So can you tell us a little bit about what machine learning actually is and how ML.net can relate to it?
Yeah, we actually have prepared slides if you want us to get into those already, because we do talk about machine learning and kind of break it down into hopefully simpler terms for people who might not be familiar with machine learning. So if you want, I can go into those.
Let's do it.
Yeah, so I'll be sharing my screen. We did our intros already, so we'll go past this. And Louise, why don't you talk a little bit about the definitions of machine learning and then tell us about it.
For sure. Yeah, let's do it. I think for this one, the visuals really help because oftentimes you're going to hear artificial intelligence, machine learning, deep learning. You're going to hear all these terms and they're going to sort of sound like they're the same thing. And to a certain extent, they kind of are, right? So like if you take a look at artificial intelligence, it's sort of the higher sort of level concept. And essentially what that is, it's just, anything that would otherwise be something that a human would do if it's automated or if it's done by some sort of agent, technically that's considered, artificial intelligence. So you can think of, setting rules in your inbox, right? Technically, you're not the one that's filtering your messages. You have this program that's running in the background that's doing it automatically for you, right? The problem there though is that it's rules based, right? So you're the one that has to define, perform these actions based on these rules that I have defined. And you can imagine that as programs get a little bit more complex, it can be difficult to keep track of all those rules, right? And handle all the conditions. So that's kind of where machine learning comes in. So with machine learning, you essentially just get computers to take a look at data, take a look at real life examples, and learn from that historical data in order to try to understand the patterns that are there in the data. And based on that, come up with what the rules should be for predicting outcomes or determining certain behaviors. And then sort of a level below that, you have deep learning, which is a specialized set of algorithms known as neural networks, which typically they're thought of as being modeled after the brain, but essentially the way that they work is the way that they process their data is in such a way that they're really well at handling data such as images and speech and text. So that's why a lot of implementations say your agents, right, that you talk to, Alexa or Google Home or whatever, right? A lot of those tend to have deep learning models or use deep learning algorithms in order to handle your speech patterns and things like that. So that's essentially a rough breakdown of what these terms mean here. If we were to sort of visualize that a little bit here, if you were doing something with artificial intelligence and you had these two pictures and you had the task of trying to determine, okay, well, which one is bread, or is it bread or is it not bread? If you were to use artificial intelligence, that would be a lot of if statements, right? And there's a lot of abstract concepts, especially with computer vision and visual information, that the computer, to us, it seems sort of pretty straightforward, but the computer doesn't know, what an edge is or what an ear is and things like that. So you would have to code that, right? So how do you go about coding that? Eventually it gets too complex. So with machine learning, you just give it examples and you give it images, and using something like, say, a neural network, right? You're able to tease out patterns that would determine, okay, this, based on these examples, I know that this is a piece of bread, and based on these other examples, I know that this is not bread, right? So that's kind of how they differ there.
I don't know about you, but I can't tell the difference between the two.
I know, it's so uncanny.
I just want to take a bite out of the plug there, but please don't.
Have you ever heard that expression? There's like an expression that's so cute you want to eat it with a spoon.
I know. Both are very sweet. Like if you get like the challah bread or brioche.
Yeah, exactly.
Yeah.
They both got rolls. So yeah, it just makes sense. Yeah. So in terms of what the way that you should think about addressing machine learning, a lot of times you often hear the questions like, okay, well, how do I start, or like where do I start? And really it all kind of starts with a problem, right? And you have this problem that you're looking to solve, and that's really the place where you should start. And depending on that problem, there's typically a task or some sort of algorithms that could help you solve that problem. So if you're doing something like finding outliers, right? So finding something weird that happened, perhaps in like a credit card statement, there's a transaction that looks odd. You might want to use something like anomaly detection for that, right? If you're trying to predict numbers such as, the price of a house, or you're trying to forecast sales, regression and forecasting algorithms would be really useful in that scenario. If you're just trying to find relationships, right? So let's say they have like a customer database, and just trying to tease out patterns. You don't really know how your customers organize, but maybe based on when you're using clustering algorithms, which as the name sort of suggests, you build these clusters of customers, you start to tease out and understand patterns like, maybe a lot of my customers live in certain parts of the country, or they buy a certain group of products. And based on that, you're able to make a little bit more sort of educated guesses and get more information about who your customers are. If you're looking to categorize items, this was actually like a pretty common one. We're always trying to, put things into categories. So, for example, spam or not spam, right? That's something that you could do. Bread or not bread, all those types of things. Those would be served by these classification type of algorithms, right? And then last but not least, this one that we're probably all familiar with, which is making recommendations, right? So the Netflix, the Amazons, and so on and so forth.
Everyone's favorite.
What was that?
Everyone's favorite.
I know, right? It's almost like they know you too well. It's like
yeah.
I didn't know that I needed that.
Right?
Yeah, I don't know what I'm going to get. Yes. So algorithms can get that good that they know you better than you know yourself. So how do you go about building these machine learning applications, or what is the process? It's actually pretty well defined. Now, within each of these steps, there's sort of like leeway, right? It's very experimental because the data, you start off by getting the data. Now, as we all know, when you start off and you're sort of doing these toy problems, right? Examples, a lot of times the data is going to be pretty much very clean and easy to process. Maybe the data set's going to be small, but in the real world, that's probably not going to be the case. You're going to have duplicates. You're going to have missing values. You're going to have, conflicting information. So you're going to have to prepare that data and get it into a format that the algorithms themselves can actually use to, try to understand the patterns, right? And now typically algorithms, they like numerical data. So kind of like I was telling you earlier, right, with the images of dog, bread or not bread, the computer doesn't know what an image is. It doesn't know what an ear is. It doesn't know what an eye, and it doesn't know what these features are, right? So you have to define it for the computer and break it down into numerical values, which the computer can process, right? So that's the data preparation, and then in the training, that's when you select an algorithm that you're going to use to try to solve the problem that you're trying to solve. So this was the regression, recommendation, anomaly detection type of algorithms. And once you have trained an algorithm, you can go ahead and evaluate it, right? And you want to take a look at different metrics to try to understand, okay, well, is my model performing the way that I would expect it to based on these metrics? Now, these may differ, right? You may have different thresholds. Often you hear the question, is my model good enough, right? Well, it depends. I don't think anybody likes that answer, but it really does depend. If you are trying to diagnose somebody with, critical condition, right? The threshold for good enough, it's going to be pretty high. If you're trying to determine if something's bread or not bread, maybe not that high, right? So it really does depend, what those thresholds are based on your scenario and what you're trying to do. But once you've evaluated it, that's at the point, at that point, if it's good enough, you can go ahead and you can deploy it, right? And there's typically the way that you do that is you set up some web API to expose it over the web, and you make predictions over HTTP. However, a lot of times it's a lot of trial and error. So maybe your model is not good enough, in which case you probably would either select a different algorithm, or you would prepare your data again, or change the data, add more data, perhaps if you didn't have enough. So it's sort of like a continuous loop that takes place here during this training process. That it's very experimental. It's very trial and error. And then at that point, once you've deployed it, then you can start inferencing, which at that point is really just sending over some input, using the model to make predictions, and returning an output. Throughout the life cycle of the model, you're going to want to essentially retrain this model because things change. A perfect example was this past year with COVID, right? Like perhaps you have this forecasting model. Let's say that you work for some tourism company, right? And you're like, oh, summer's going to be great, and we projected that this many customers are going to show up, and then COVID happens, right? The models, they don't mean anything. Like they're worthless because now you have new information. The state of the world has changed, so you're going to have to go back and retrain it based on the new conditions in the world, right? So that it's a constantly ongoing process that takes place here. But typically, these are the steps that you would follow to train as well as deploy and consume a model.
Cool. So on this topic, before we go into ML.NET itself, we do have a question from chat asking, how does GDPR play a role in machine learning? Because it's all data. As you mentioned, machine learning, sometimes the computer knows you more than you know yourself. So.
Yeah, that is super interesting. So GDPR can certainly help inform, how you manage the data, right? Like I know that, for example, like I think it's Street View or Maps on Google, right? Like you have the option of removing yourself from those images and things like that. In which case, if those images were being used to train a model, you'd get to opt out, right? So GDPR sort of, I guess I like to understand a little bit more where this question is coming from. But as it pertains to data, right? There are a lot of ways and a lot of practices or techniques that are being used nowadays, right? To try to be a little bit more responsible with data. Now, regulation certainly helps with that, right? So GDPR is regulation that helps preserve the privacy of folks, right? So for example, if I don't want my data being used to train some algorithm, right? I have the choice of doing that. So regulation certainly is a role, but there's also techniques that are out there which still use your data, but the data is anonymous in the sense that you're not really you can't really tell like whose data this is, right? So GDPR plays the role in the sense that it helps give people options and choice of saying like, hey, I don't want my data being used in certain instances.
And I think there's an example of that with credit cards. There's this famous credit card fraud detection data set where they like hash all the values, like all the features, so you don't even know what really the features are. And so it makes it so you wouldn't be able to identify anyone from that information. So it's really, like you said, it's just really important to remain cognizant of, data privacy. And I think we even had a training here at Microsoft where the standards of business conduct where they use data they weren't supposed to for training. So obviously if there's this data that you're not supposed to use for training a model, you shouldn't use that. And like there'll be different guidelines to help inform that. Hopefully that answered your question.
And I think there's also, it creates an accountability for the ones who created the model. Like you can't hold on to that data for all time or anything. Like you have to get rid of it or throw it out or destroy it altogether after a fixed amount of time.
Right.
Yeah, and there's also the, making sure that there's not bias in your data. That's another important one. That's not necessarily like GDPR related or data privacy, but that kind of comes into like model fairness and explainability.
Yeah. I think it definitely falls under that sort of umbrella, right, of being like responsible throughout the whole life cycle. Like you want to make sure that that you can use the data, that you've been given the permission to use that data for training, that you're disclosing to folks like, hey, if we use your data, this is what your data is being used for. And going back to where you're mentioning, right, like making sure that it's not when you do train those models, you want to make sure that they serve everybody and they treat everybody sort of fairly.
Yeah.
All right.
Yeah, there's like a whole. I think we even had a class on like ethics of machine learning.
Oh, too. Nice. Maybe.
Yeah, I was like.
We should have taken that, or we should take that now.
Nice.
Are there any more questions, Leslie, before we move on to?
I don't see any, although Paul Snable, I think managing the training data sets are harder than the actual model.
Data is the hardest part of machine learning. Choosing the algorithms and everything is also, the algorithms and the hyperparameters used for training is hard, but definitely the data prep and managing the data, getting the data is definitely, I would say, the hardest part.
Yeah.
So
Cool.
very true. Awesome.
And
so ML.
oh, wait.
Another question?
One more question. Yep.
Okay. Yeah.
So Snowspa asks, how do you check that there's no bias in your data because you have to GT model, or because you need to have GT model to evaluate its generalization?
I'm not sure what GT model means. Do you know what that means, Louise?
No, yeah, I'd ask Snow Spa to sort of expand on what they mean by GT. But I will say, and not to detract, we actually just did a machine learning community stand up on this topic specifically because the team is definitely looking. Oh, ground truth.
Mm-hmm.
Okay. Yeah, so we actually just did a stream on this specific topic. So you can actually, if you go to, .NET Live TV, right, and you look up under machine learning, you can certainly find our latest one there where we talk a lot about these topics. But to give it like a short story, a short sort of answer there of like, how can there be no bias, or how can you check that there's no bias in your model? You're right that there needs to be some sort of ground truth of like, here's how my model performs across. And then you also need to sort of like measure it across different groups that are affected by certain things. So you need to set up some boundaries and some metrics, and kind of like you sort of imply, Snowspa, that there needs to be sort of this base that you work off of, and then you identify, okay, if this is my base, the base for my model, is everybody else being treated fairly, or is the accuracy or whatever metric that you use to measure how good your model is it performing the same across various groups, right? Demographics, whatever that may be.
Cool. Is it, out of curiosity, is it the stand-up called Model Explainability? Because I can share it in the chat.
It is, yes.
That's it.
Awesome. Great.
Yeah.
Cool. No further questions, Your Honor.
Awesome. So awesome questions so far, and hopefully now you're all experts on Machine Learning 101. And that's where we're going to move on to ML.NET. So in the machine learning landscape, there's a lot of different frameworks and technologies you can use. Mostly they're Python based. So ML.NET is an open source and cross-platform machine learning framework for .NET. So you can train custom models in .NET, and you can consume pre-trained models as well. And it runs anywhere that .NET runs. So it really is cross-platform. You can run it on any cloud locally. A little bit of the history here. It started out, the framework started out as an internal, Microsoft research project for text mining and search, I think like 12 years ago. That evolved into an internal framework called TLC, short for the learning code. And that framework has been used internally at Microsoft to power machine learning features of Microsoft products for over 10 years. So that evolved, and in 2018, we made that open source. We made it a bit more .NET and public friendly, and then released it at Build, the first public preview in 2018 at Build. And then the next year was the first GA release, as well as the tooling. And earlier this year, TLC was deprecated. So actually now internal teams are starting to move to ML.NET as well. So just a little bit of the history of how we got to ML.NET.
Oh, so 12-year journey, it sounds like.
Yes, it has been. ML.NET, like I said, is built for .NET. So it allows developers or data scientists or hobbyists or students or whatever that want to stay in the .NET ecosystem to use their existing skills to integrate machine learning into their applications. It also doesn't require data science or machine learning experience based on the tools and features that we have, which after the next slide, we'll get into Visual Studio and show how you can do this. And because it is .NET, it makes it really easy to go from that experimentation process that Louise showed off in the workflow side to production. Because if you're working in, say, Jupyter Notebooks, or you're working in Python, it's not super easy, and it's actually a big industry-wide problem right now to go from that experimentation and training to production. So the fact that this is in .NET makes that a lot easier. And what can you do with ML.NET? Louise went over a lot of these tasks already, but there's classification. So this could be automatically adding labels to GitHub issues, which actually some of the .NET GitHub repos, they already use ML.NET for auto-classifying and auto-adding issues. You've got regression, which is when you want to predict a value, like if you want to predict the price of a used car based on the make, model, mileage, and so on. Forecasting, which is predicting future values based on past values. So that could be like sales forecasting, weather forecasting. You've got anomaly detection, like if you want, say, alerts when there's network intrusions, you could use anomaly detection for that. Obviously, there's a lot more use cases. I'm just listing one for each to give a better idea of what these are. Then you've got ranking. So this could be like search results ranking. So that's something that Bing would use. Clustering, which would be things like customer segmentation. So this is when you don't have labeled data, but you can still find patterns in those data, in that data. Then you've got recommendations. So that's where you've got your, you may also like. And then, so those are all what we consider classical machine learning tasks. When we're talking about deep learning, that would be things like image classification and object detection, which you can also do in ML.NET. And the difference here is image classification would be, you have one image and you say this image is a dog, this image is a cat, versus object detection is you're identifying and detecting if you want multiple objects within one image. So you could say in this image, here's the cat, here's the dog. So you can do all these things with ML.NET. That's
great. And it's nice to have this library of tools for those who are not for those who are new to the ML space, because I remember being in college and being like, oh, ML is so cool, I want to try it out, and just being so intimidated by all the knowledge that you need to know just to be able to start. So yeah, it seems like this is like a nice level playing ground in a lot of ways.
Yeah, and we always emphasize that, like, we're not trying to pull people who love Python and want to work in Python away from Python to ML.NET. We just want to enable our millions and millions of .NET developers to be able to do machine learning in .NET. So even if you had, say, a .NET developer that worked with a data scientist and that data scientist worked in Python, there are ways where you can export those Python models, and I think someone had a question about this, and then consume those in ML.NET. So specifically, you can consume TensorFlow and Onyx models in ML.NET. So still, we're not trying to force those data scientists to work in .NET if they don't want to, but it makes it a lot easier to integrate back into an application if it's using .NET and not trying to integrate Python back into .NET.
Awesome. Yeah. So the option is there.
But I will throw one out there as well. So there's been a lot of talk of F# this whole month. But if you like Python, but you're also kind of in the .NET space, F# is actually a really nice sort of in between, right? Where it's like super succinct. It kind of almost looks like Python in a lot of ways. But you also get, the access to all the .NET libraries. So, that's also an option for folks.
Great. Yep, I love options. Demo? Yay, I love demos. Let's do some demos.
Awesome. Let's finally get into Visual Studio. This is Visual Studio Toolbox after all. Awesome. So right now I'm just in VS 2019. I have created a .NET Core, or actually no, I think it's a .NET 5 console application. Right now, all it does is print hello world to the console. So from this, I'm going to show you how you can train and consume ML.NET models and how easy it is to create a machine learning model with ML.NET and its tooling. So the scenario that I want to solve is I want to predict, and this is a pretty classic one, but I want to predict the price of taxi fare based on features like distance traveled, number of passengers, payment type, and so on. And then I want to be able to put in new data and predict what will my taxi fare be. So in my Solution Explorer, and I apologize, it's a little small, but I'm right-clicking on my project, and there's going to be an option to add machine learning. As easy as that. So this is you're done. No, a few more steps here. So it opens up the add new item dialog, and I'm going to name my model. So I'm going to name it, let's say, taxi fare model. So once I add that, it's going to add this mbconfig file to my project. And we'll give it a second. Live streaming usually slows this down, so hopefully we'll get through this together.
Cool.
So once it does that, once it generates that, so mbconfig file in Solution Explorer, it also opens up Model Builder, the Model Builder UI.
Nice.
Within here, you can see there's a variety of scenarios, which we've mentioned all of these in the slides, that you can use for training. So the ones up top are ones that you can train with your own data, and they have implementations of AutoML, which I'll mention in a bit. The ones on the bottom are not yet supported by AutoML, but we do link to samples so that you're not left on your own for these scenarios. And we're working to add more support for being able to train with your own data through the UI with these scenarios. But in this case, I want to predict a value. So I want to predict fare of taxi or the taxi fare. So I'm going to go to value prediction. And then once I hit this, right now the only option I have is training locally with my CPU, which is totally fine for the amount of data I have. So I'll move on to the next step. I have the option to choose my data set from a file or from SQL Server. In this case, I just have it in a file. And it's this taxi fare train. And it's going to give me a preview of this right in the UI. So what it's saying, and it says it's a data preview. We've got 50,000 rows of data. And so we've got vendor ID, rate code, which these would be specific to taxis probably. You've got the number of passengers and passenger count, the trip time in seconds, the trip distance, the payment type, which is card or cash, and then the fare amount. So these are, of course, labeled data of trips that have already happened in the past. I want to select my column to predict, or what we call a label, is what we want the model to predict in the end. So we're trying to predict the fare amount. So I'm going to choose fare amount as my label.
Oh, before we go past the data part, so for those who, as you mentioned, acquiring the data can be just as hard, if not harder, than actually training a model and everything. So do you have any advice for people in regards to how to acquire that data for their own models?
So it'll depend on what you're trying to do. If you're just trying to do samples and try out and learn, there's a few different resources like UCI, Kaggle. Those are like well-known sites that have data sets that you can download and kind of play around with. For collecting your own data, it's really going to depend on your scenario and what like tech you have available. I don't know, Louise, do you have anything to add there?
No, not much. Yeah, for public data sets, those are really good. Others that are really good, that are real world, and not really just toy examples. It's at least in the US, government portal. So like, for example, New York City has its own like sort of, data repository where it has like 311 calls and taxi fare data and all sorts of data. So I would say, look through those like sort of government data portals, because chances are that you'll find a lot of really interesting data sets there to sort of like, if you just want to learn something, but at the same time you want to use real data, that's a really good option.
That's really cool. I didn't realize government portals kept all that info.
Yeah.
For free. That's cool.
Yeah. We recently added, I guess in the 2 releases ago, some more advanced data options for instance, if you want to change your column purpose, you can do that. Right now, all of these are going to be features. Features are what kind of the inputs to the model, what you're using to predict the output. So all of these are going to be features. You can also change the data type here, Boolean, string, or single, and then choose whether it's categorical or not. Like for instance, rate code. While rate code is technically a number, it might be like some sort of category that's specific to taxi fares, and that will impact the performance of the model. Model Builder does a pretty good job of auto selecting the defaults based on your data set, but if you need to override anything, you can do that in the advanced data options, including some data formatting, such as changing the column separator, whether it has a header or not. But in this case, it was all good. So I'm going to move on to the next step, which is the training step. For training, I'm going to put in a time to train, and this is going to depend on your data set size, how many columns you have, what your, I guess how fast your computer is, if you're streaming live at the same time. But as soon as I hit start training, what it's doing is it's taking in my data, and it opens this up in the output window in this little machine learning tab. And it's using this process called automated machine learning, or AutoML for short, to iterate through different models. So it's trying out different algorithms. It's trying out different algorithm options based on the data and the scenario that I gave it in order to find the best model. So right now it's going to be a little slow again because it's using my CPU, which is also being used to stream and video and everything. But you can see that it went through 4 models in the 20 second or 30 seconds that I gave it. It found the top model to be this, I'll give it a second, fast forest regression model, which is, that's the name of the algorithm. And it has this R squared of 0.86. And R squared is a evaluation metric used to evaluate our regression models. So in this case, the closer to 1, the better. And I got 0.86. So I'll say, hey, that's good enough. I trained in 30 seconds. And it found a good enough model for me to continue on with the demo.
Sweet. I feel like I just re-entered stats class with the R squared.
Right, I know. But in this case, closer to 1 is better is all you need to know.
Yeah.
I mean, you should know a bit more, but at least getting started, that's all you need to know.
Great.
Yeah, and in this next in the next step, you can try out the model right in the UI, so you don't have to go into the code and then discover, hey, it's not actually making the predictions I want, and then you have to retrain. So you can do it right in the UI. So it pre-fills based on the first row of data, just so it has easy inputs. So in this case, it predicted that the fair amount is $17 on the first row of data. So if we go here, it will be this first row, and the actual fair amount was $17.50. In this case, it was $17.11. So that's pretty close. So if we, increase the trip distance by 10, let's say 38 instead of 3.8, it should go up. So it goes up to $51. So you can see it increasing the distance, which is probably has the biggest effect on the fare amount, raises that up to $51. And you could try out different ones here.
So this is cool. You didn't have to write really any code for this.
Not yet, no.
Not yet, yeah. So
so that's pretty cool.
So like before this being able to train the model existed with ML.NET and stuff, what would you have had to do if you wanted to do the same thing in Visual Studio?
So you can totally use the API and build the pipeline yourself. And I'll actually show you the code that's generated that you would have to do yourself once I show how you consume it. So it's a whole pipeline, and I'll show that to you in the generated code. It's not difficult. It's just it's lines of code. So you would set up the pipeline, you would train it, you would evaluate it, and I'll show that to you. And actually, I now realize that my computer is not plugged in and might die. So let me try and find my charger here. Sorry, I'm doing this live.
No worries.
I definitely don't want to die in the middle of this demo.
Well, that's happening.
Feel free to stall. Please stall for me.
Yeah, while that's happening, Rizwan Tayab here. I see there's a question. Is ML Builder still in preview? When is the production version getting released? Yeah. So in terms of stability, Visual Model Builder is actually production ready in terms of features and in terms of stability. The reason why it's still sort of in preview, or it's labeled as preview, is because there's still some sort of accessibility and other things that are sort of keeping it from going into production, right, or general availability. But you're totally free to use it, and it should be very stable. And if you do run into issues, you can definitely file those in the machine learning model builder repo. So great. Yeah.
And I'm back. Sorry for that brief interruption. But yes, what Louis said, there's, a few things that we need to wrap up and really make sure, that we've got the localization down, we've got the accessibility down, and we're hoping to GA in November. So that's kind of our goal there. But it is still, even though it's in preview, it's still like all the functionality is there. People are still using it for production level models. So it's totally usable right now. It's just a few things to wrap up there.
Great.
Yeah. So moving on in the demo, I now want to, my model's good. I evaluated, I think it's good enough. So I want to try consuming it in my console application. So all I've got to do here, it gives me the code for consumption. So I'm going to copy this code. Yeah, right. Still haven't written any code.
Nope.
So I'm going to come over to here, and I'm going to replace this hello world with the code that was on this consume page. And I'll walk you through it. So first, you're going to create this new model input object, or I guess taxifare model input object. And you can see that there's all these kind of properties to set. And this is based on the first line of data, but I can change it to whatever I want. I could hard code it, or I could have user input, which is probably the most likely case here. And then I'm going to take that input, that sample data, what we're calling sample data, and I'm putting it into this predict function to return a result. So let me actually go into these methods so you can see what they are and what they look like. And that's going to be in this taxifare model.mb config. Right when I hit train in Model Builder, once it was done training, I guess I should say, it generated these three files. You've got taxifare model.zip, which is your actual ML.NET model. ML.NET models are these serialized zip files. It came with this consumption.cs file and this training.cs file. So going into consumption.cs, you can see it creates this model input class. So again, this is going to map to all the different features that you want to input into it. It also created this model output class, which is going to return a score. This is going to be the output of the model, the score being the fair amount in this case. And then you've got this functionality here in this predict method. So if you were doing this in code and you didn't have this code generated, you would have to create a new ML context. This is kind of the starting point for all ML.NET operations. It's kind of the catalog, kind of like a DB context and entity framework. So you can find all the ML.NET operations within the ML context. So you'd create an ML context, you'd load in your model with the model.load function. And so this is taking care of that for me, loading the model. You then create a prediction engine. So prediction engine is a convenience API for making single predictions. You use this model input and model output classes here for the schema of what the model will expect. And then you put in your model that you just loaded in. From there, you'll create this new model output result. You'll call the predict function of the prediction engine on the input that you give it from this model input. And then you return the result. So we've just kind of wrapped that all into one predict function that we generated. And so when you come back to your console application, here's that model input that was generated. And then this is going to return a model, if you can see that, a model output from the predict function here on the sample data. The second file that is generated here is the training.cs. So this is also super important. This is going to be the pipeline that AutoML chose. So that you could retrain if you wanted to, or just to be able to explain your model. So I'll kind of jump down here to the pipeline. You can see there's some data transforms. As Louise mentioned, algorithms need numbers. And so, there's there's this replace missing values, one hot encoding for categorical data, and a few others that AutoML chose based on the data that I gave it. And then later on in the pipeline, you come down and there's these trainers, or algorithms for the regression task, and it chose this fast forest regression algorithm. If you remember from the UI, this is the one that was selected as the best trainer. And then it also has all these options here. So it auto tried these options and then chose this one as the best one in the given amount of time. So, and then it returns that pipeline. So this is, Leslie, what I was talking about before when you would have to define it all yourself.
Oh man, yeah.
First approach, which again, it's not like that much code, but it's like,
how do you wrap your head around? Exactly. Yeah. But the feature fraction alone under the fast forest regression trainer, it's just like, whoa, good luck trying to figure that out. Yeah.
Yeah. So that, and again, this is really important because one, being able to explain your model and understand what's happening and how it was built and trained. And then the second one is if you're continuously getting in new data and want to retrain on the same pipeline, you could use this for retraining as well.
And I bet it's great for those who are knowledgeable more in ML, and if they wanted to tweak any of this, that they could do.
Yeah, and it's also a great learning tool, right? Like you start with Model Builder, you get this code, and then you can tweak it on your own to see how that affects the model. So
gives way to a lot of fun experimentation without it being tedious.
Exactly.
Yeah.
It gives you a good starting point. Exactly. So going back to program.cs, I want to show you how this runs in the console app. So right now, nothing's printing to the console. So let's just do a write line so we can see, let's say predicted fair. And we're going to return result dot, if you remember in the model output, it was result dot score. And so I've got that code here, and I'm going to run the console app. So you can see what the predicted fare is. And it should be close to that $17 that we saw before, or $17.50 was the actual result. So we'll give it a second to build errors live. What is going on? Okay. I'm sure it's something. What? Louise, help me live debug here.
I can't see.
You can't see? It's too
no.
This is not
it says a lot of different things cannot be found, or the DLLs specifically.
Have you tried turning it off and on again?
All of you online, whoever debugs this will get a big congratulations. It has something to do with .NET 5. Okay, it's going to be the classic, like I ran this right before and it worked. Okay, let me try. It's in CS Proj. Let me check out my CS Proj real quick and see what. Oh, that's not my CS Proj. This is my CS Proj. Apologies for this brief interruption. So it says something about .NET 5 here. Reboot the machine. Well, that might take a while, especially considering my machine. Let me just try, and if I rebuild the solution, maybe some magic will happen. You just never know, So let's give it a go and see what happens.
I think the machine learning model learned that you don't like it when your demos crash in live settings. So
Yeah,
it
right.
decided to just troll a little bit.
It has something to do with .NET 5, which I'm trying to think if I like updated my version before. So it said, if it doesn't work,
Right.
buy a new one. Okay,
Yeah.
well, if you want to buy me a new one, that, you know, I wouldn't mind.
To anyone who ever has to present anything, do not update anything prior to
Right before
your presentation. Yeah, it bites
I
me.
really want to show you how this works. Okay, so that should be
try
fine.
it. Yeah, if this doesn't, try adding the solution to console app. Maybe that one will work. In the
Do
consume
what?
step. In the consume step, try adding the console app instead of
Oh,
your code in
okay.
here.
So I think what happened is it's trying to find this model that this thing I deleted. Let me try again. Okay, I think I know what's going on. I don't know what's going on. What do you mean? Now it's saying that I don't have the .NET SDK installed. Anyway,
maybe try closing out of VS and then coming back in.
Oh, that might take a second. Let me. Oh, moving. Yeah. So I also thought about moving back to 3.1. I think I might try that and see what happens. So let's see if I can remember how to do this. So we'll try moving to 3.1. If that doesn't work, I'll try restarting Visual Studio because I do want to show you this running in a console application. Oh, that seemed to break. Did that break something?
No, I think it's just the code behind that.
Okay.
That switch, but I think you should be able to run it still.
Okay. All right, everyone. Moment of truth. Okay. Let's give it a go. Okay, everyone's saying restart Visual Studio, so it seems like that's what I should do because everyone's suggesting that. This has literally never happened.
I'll do magic in the meantime.
So weird. Okay, I'm going to restart Visual Studio, everyone. Bear with me. Louise, stall. Hurry.
Yes. Well, I'd just like to say hello in the chat. Fuel, Janice, Q7. Thanks for joining us. I know that you folks often join us for these streams, so thanks for sticking around. And welcome and hi to new friends. So if you just joined, we're actually trying to run a machine learning model that predicted taxi fare apps.
We're trying. We did build the model. It was the console application that didn't want to build. I should have ran it with the hello world, known that it wasn't going to build.
It is. It is.
Do something. I'm working on restarting Visual Studio. So.
Yeah.
But if anyone has questions about ML.NET, obviously, or machine learning, while we're doing this, while we're live debugging here, feel free to ask. I don't know if we missed any in the chat, but we're happy to help answer questions.
If makes you feel any better, it makes the whole process to get to the command prompt
and something that we didn't really like show here as well, or we didn't really talk about is the CLI, right? So in terms of tooling, ML.NET has Model Builder, which is this really nice UI, but you also have the option of UI, and it handles a lot of the really pretty much the same scenarios that Model Builder does, except of course it's in the CLI. One of the advantages there also with the CLI is that because it's a .NET tool, you can use it on Mac and Linux, right? So if you need that cross-platform support, you can certainly leverage the CLI. The other cool thing that Breek sort of mentioned with the MB config, right, is that you can use it across the tooling. So let's say that you start in Visual Studio, and then for whatever reason you need to use it on, I don't know, a Mac or Linux. You can just take that same MB config and use it with the CLI, right? So it's transferable because at the end of the day, I don't think Bree showed it, but essentially that MB config is just a JSON file, right? And all it's telling is like, here's where you find my data, here's how long we trained for, here's like the metrics that we had for this particular model, right? So it just kind of like saves the state for your training process, so you don't have to sort of restart. And the other thing for the CLI, right, that I'll sort of mention there is the one of the really good use cases or scenarios for that is sort of I alluded to earlier, where it's like this process is not one and done type thing, right? You don't just train it and then you just forget about it. It's one of those things that you sort of continuously improve throughout time. Sitting there, especially if you have a lot of models, sitting there trying to be like, oh, is this model working? Let me go ahead and retrain it, right? It can be time consuming. So you probably want to set up some sort of like automated way to do that. And the CLI can come in really handy, right? Because at the end of the day, it really is just a .NET tool. You just install, let's say, in Azure DevOps or GitHub Actions, right? And you just run it like you would any other sort of command line script, right? So that's certainly an option as well if you're looking at the tooling. And of course, you always have the option of going for that code first approach, which is going to give you the most flexibility out of all these things. I do see that we have a question from Intern Ops here. What about GPU support? Yeah, so you actually have GPU support for training and for inferencing. So if we're talking about the training aspect, you can train locally with Model Builder using GPUs, right? So if you have a GPU on your machine, you can certainly use GPUs to do image classification or solve image classification problems. And the reason for that is, image classification is very resource intensive, and the GPU helps accelerate that. I think, this has been a while since I've done tests, and I could only imagine that it's improved since then. But I remember I was training with like 27,000 images, this one model. And when I used my CPU, it took like 5 hours. So yeah, it can be time consuming. But when I use my GPU, it took like 20 minutes. So, that's when you want to have that. So for training, you can certainly do that. If you don't have a GPU, that's okay, because you also have the option. Bree showed off that for the value prediction scenario, right? Which is trying to predict the number. Local is the only environment that you can train this in, right? So your local PC. But with image classification and object detection, these deep learning scenarios that are, again, very resource intensive, you have the option of training on Azure, right? So you basically send your data up to Azure. You can leverage the GPUs on Azure to train these models. And then the models are then downloaded onto your PC, and you can continue the workflow just like you would here, with this md-config and with the predict function and all that. So everything works pretty much the same. It's just that now you're performing that training and you're doing it all in Azure.
Yeah, and that works for right now image classification and object detection from Model Builder. We are working to add support for all our scenarios for both local and Azure, just in case you have a lot of data or need the power of Azure to help with training. So I think restarting Visual Studio did the trick. Thank you, everyone who suggested that. I should have known it was turn it off and on again. So you'll see. Oh, let me zoom into this. I just ran the console app. I promise it wasn't fake demo magic. I ran it. Here we are. Predicted fare. We finally got here together. So you can see the predicted fare is $17.11. So that's running the model. There should be just a restart button. Is there a restart button in Visual Studio where it's like turn off and on, or I don't know?
Yeah. just try installing an extension. That'll force you to restart.
So that's how it works in the console application. I wanted to, Leslie, how much time do we have?
I've got like 10-ish minutes, give or take.
Okay, cool. So I'll quickly show. We'll see if this one works. I think this was the image classification example that that Luis was talking about that I trained in Azure ML, because it takes a lot of time and it was like a ton of different images. Actually, I can tell you how many images. It was 17, almost 18,000 images that I trained on. I didn't want to do that now. So what I did is I had 2 classes. I had pictures of non-vehicles and pictures of vehicles. And you can imagine using this for something like self-driving cars. So say your taxi was a self-driving taxi. Obviously, you would want to have a very high performing model. Yeah.
Yes.
Don't use this model that I created here. But you can see I did this, and I trained in Azure with this. And I'll show you. It says this one said 1% accuracy, but it actually is working pretty well. Obviously, don't use something like this in production. But let's try a test image. This is how you would evaluate image models in Model Builder. So this one should say predict that there's a vehicle there. So it's using the model that I trained in Azure to predict that. And it might take a second because its image data is going to be a lot. It's going to be a lot bigger than just a simple line of text.
Cool. And I'm assuming you can combine the different kinds of ML use cases together into one program pretty easily with this, right? So like if you wanted to do like ranking and image processing in the same program.
Yeah, totally. You can have as many models as you want in one application. People will use like Microsoft Defender. They use ATP. They use like I think, thousands of models for different things, including and they use ML.NET. But if you can see that it's predicted, it's 81% confident that there is a vehicle in this one. And I'll show off again. So you should see it's not, we have a test image too that has none. So we'll give it a second to predict. Then I want to train one more model, and I should be able to do that in 2 minutes. And I want to show you how you would be able to deploy that, which is ironically probably going to work better than the console application because that Visual Studio is giving me issues. But you can see I tried out my model, and it said it predicted at 65% certain that there's not a vehicle in this. And I see someone said, "Too late, I shipped this model already." Good luck. Please wear your seatbelt.
Safety first.
So I'm going to add another model here. And I wanted to do sentiment analysis. Say I leave a review of my self-driving taxi, and I want to predict whether it's positive or negative review. This is a pretty classic machine learning, getting started, hello world type thing. Mm-hmm. So again, it's going to open that add new item dialog eventually. I really got to switch to VS the next 2022, is it?
Yeah. We use code names for everything, so I always use the actual year of VS. Yeah.
So I'm going to call this review sentiment model. And it's going to do the same thing where it's going to create that MB config. It's going to open up the UI, and I'm going to train a text classification model. And something that I didn't mention before, this MB config that gets generated is just a JSON file that saves your state. So if you open it up, you just see it has all the different state of the UI in there. Nice. I'm going to do this text classification. I'm going to train locally with my CPU. I'm going to train with this Yelp labeled data set. This is a public data set, and it's a bunch of Yelp reviews, I think 1,000 Yelp reviews, and then the sentiment, so whether it's positive or negative. And so you can see comment, wow, love this place, sentiment is positive. I want to predict the sentiment. And we'll give it a second to register that's going to be my label. And then I'm going to train. So let's give it 75 seconds to train, just because, again, using my CPU and all this may take longer to find the first model. And again, this is doing that same thing with AutoML.
Cool. So what's like the ideal number, assuming you do have more CPU power, or just have a powerful machine altogether? Like, what would be the ideal amount of time that you'd want to train the model for?
Everyone's favorite answer, it depends. So it really does depend on like how much data you have, say how many features you have, how big the data set is in general. It's going to depend on your model and your use case and your data. We're actually investigating right now, especially for deep learning, is time even an accurate representation of progress? Or should we look more at, the cycle that it's in and its training, or, how maybe you want to stop it. Maybe you want to go up until it gets to a specific, like a certain accuracy. So those are things that we're kind of investigating right now, because time is not always like the best metric for everyone.
Gotcha. It sounds almost philosophical too. It's just like, is time really related to progression in life?
I don't know where so something else, let me make sure that I actually hit start training. Something else that, oh my gosh, Louise, what is happening?
I don't know. It's not liking you today.
It's not liking
you for work.
This is the first time a demo hasn't worked for me live. I really did jinx it. I know. But we'll let it go. So something else that I want to mention that we're working on is, so you could see like I kind of stopped training and restarted the training. Something that we're adding soon, or something that we're working on, is adding something called continue training. So say that I trained for 60 seconds and I did not get a model that I want, like that was a good model, or I deemed it a bad model. I could add more time to that, continue training after the time is over, and use the previous history of training in order to get a better model. So, or if I put an hour to train and within 1 minute I get a high performing model, I would be able to pause training and use that model versus having to wait out the whole time.
Great.
No, I did not perform the Twitch required blood sacrifice before the stream. That was my fault.
Gotta do it.
Really my fault.
Missed it in pre-show prep.
Never schedule your demos on the 13th.
13th, yeah, that too. It is finalizing the model, which is great. So I found a model with 69% or about 70% accuracy with this fast tree OVA algorithm. I'm going to evaluate and say, wow, love this place. Let's see. If we put the car smelled bad, we'll see if it picks up that bad. It might not based on the model. It is. So it says it's 53% positive that it's negative. Certain that it's negative.
Yeah.
So now I have this model. I'm happy with it. Obviously, not in the real world. I'd want more data, and I wouldn't be super happy with it. But I'm going to push these changes. Let me save first. I'm going to push these changes, and because I don't know how to deploy this, I need Louise to come deploy this. So I'm going to say add sentiment model. I'm going to commit. And then I'm going to push those changes, and Louise is going to pull those changes and deploy that to a model in these next 3-ish minutes.
Yeah, I said I was going to do a magic trick, so let's see if I can pull it off.
Cool.
So let's switch over to the screen here. And what I'm going to do now is I'm going to go ahead and pull the changes such that, okay, so we're going to use this save changes, don't save. Let me just get the latest changes from Bree. And after a while, we should see the changes reflected here. Now, one of the really cool things about this is that because it is .NET, right, it was trained using .NET, and now I want to go ahead and deploy with .NET, it's super easy and seamless to do that, right? I don't have to go rewrite or do it in Python and call into a Python sort of web service. I can just call from .NET, right? And the other benefit that you get with .NET is ASP.NET. It's super performant, right? So you sort of get that for free just by using, ML.NET and ASP.NET to deploy your models. Now, for some reason, I'm still not seeing it here.
Oh, yeah, it hasn't pushed my changes yet because I think, again, the streaming is really...
it slows it down, definitely.
What I can do is I can show you this model here and kind of what it looks like. So here's a finished version. You can still see my screen, right? Yep. Okay. Mm-hmm. So what you can see here is at that consume step that Bree sort of showed off here, right? Let me see this right. Config. When you go to this consume step, right, you have the option to deploy to a console or ship your model to a console app or use it in a web API. When you go ahead and click add to solution, and in this case it says add again, but when you do it for the first time, you add it to your solution. What it's going to do is it's going to scaffold an ASP.NET Web API project, and it's going to bring that mvconfig file. It's a little bit hard to see here, but it's going to bring that mvconfig file along with the model itself into your Web API project. If we just go into the program.cs, this is something that we're experimenting with, and I think some of the ASP.NET folks have been showing off some demos of this. Though it looks a little bit different, which is minimal web APIs. So typically, web APIs, they can be a little bit hard to get started with because there's the starter file, and there's all these things that you have to think about, all these files that you have to think about just to get started. Now, because our service is super lightweight, we just need a simple endpoint, just a single endpoint to make predictions. And what that's going to do is it's going to basically take in a request. It's going to go ahead and process that request, deserialize it, use a prediction engine pool, which is like a prediction engine, make the prediction, and return that back out to the user, send the response back, right? Now, I'm not going to go ahead and do it in here because I could kind of show you what this would look like if I were to deploy it locally. But what you could do is, because this is just ASP.NET, you can right-click, publish, go through that flow of publishing a web application to app service, to a container registry, or whatever it may be, right? Which is going to basically create the profile for you. Then you just go ahead and click publish. Once it's published, it's going to create an endpoint for you in Azure, which we can go ahead and there's this one here, right? So this is the endpoint on Insomnia. So here's the endpoint with the the predict endpoint at this URL here. And this is the body, that sentiment text. Now, this is going to be the same schema as that model input, right? And when I go ahead and send that, well, it's not going to be a surprise. It should show up what was there already. So for this interest of time, I should have just shown you that. But essentially, what you're going to get at that point is that prediction or your model output, which is going to be positive or negative. In this case, the trip was bad. It thinks it's positive. Again, we could have a better model. And where it's going to show you basically the probabilities, like how confident am I that it's positive, how confident am I that it's negative type thing, right?
Gotcha.
So it's really that easy to basically take the model that you just built and then just go through your same process that you would go through with ASP.NET applications, right? Or right-click publish, or even, at some point, maybe set up a script, some Azure DevOps tasks to deploy your model. It really is, the stuff that .NET developers are already doing.
Awesome. Well, that's really cool. It's I just like seeing how streamlined that process is from start to finish, with just being able to quickly train a model and going from there while still having those options to make it more refined and more accurate ultimately.
Yep, for sure.
So we do have a couple last minute questions before we wrap up. So first question is, we've tested ML.NET for image classification, but we always get very low accuracy. What do you recommend to enhance it?
Yeah, so it'll be kind of like the example that Louise just showed, where it said that this is a bad trip was positive. That's not a good enough model, obviously, and you would have to go back and retrain that. And there's a few different things that you can try. One is adding more data and making sure that that data is relevant, especially for image-based ones. You have to have, in a lot of cases, you have to have like a lot of, say you're doing cats versus dogs, you have to have a lot of different angles of the cat versus dog, right? Just kind of to mimic what your real world data coming in is going to look like, and making sure that you capture all angles of that. So it could be that you need to add more data. It could be the algorithm being used. I'm not sure if you're training with Azure or with the API or through Model Builder, but definitely the algorithms that you choose can determine it, the amount of time that you give it. Although I think the Model Builder case, it's not time-based. It's just based on when the experiment finishes. And it could be reframing the problem. It's really hard to tell like one specific, like we would have to know your specific use case to help out, which feel free to reach out to us on Twitter or on the GitHub repo, and we can look at your specific use case to see how to improve it. But generally it's more data, relevant data, tuning the algorithm or changing the algorithm.
Great. And last question is, so every time you train, do you have to have, or do you get access to the multiple versions of the model? And can each one be retrieved and referred to at runtime?
Yeah, I'll answer that first one. So every time you train, it will rewrite the current model, but we are currently working on our versioning story. So in the next few months, hopefully, or the next few releases, we'll have something for being able to keep track of the different versions. And so when you retrain, you will have a different version of the same model. Right now, if you want to get a different version of that model, I would suggest creating a new model and comparing it, just so you don't if you don't want to lose progress of your old one. That's what I would suggest for now, but we are about to add that in tooling specifically. But maybe Louise, do you want to comment on that?
Yeah, I was just going to add real quick. If you want a version, GitHub, right? That's a really quick way. It's a little bit more manual, and it's not specific to this, machine learning, task, process, whatever, right? But it's a really good way because you get the pipeline code generated as well as the MB config. If you just check that into, GitHub or, whatever Git version control system, that's a form of versioning that you can get there.
Yeah, great. And because this kind of transitions into our final thoughts, resources, and stuff, one person asks, can you recommend any articles or examples on prediction model training for devs and above their head when it comes to data science?
Yeah, well, Louise is a content developer for us, so he has written a ton of great docs. We also have a ton of samples, which I think we have a few banners for.
Yep. I do put some up in chat.
Yeah, and the other one that I'll call out is if you are a little bit more visual and you like videos, John Wood, just look for John Wood ML.NET on YouTube, and you're going to get a lot of introductory videos that will kind of walk you through demos similar to the ones that we've done. But also, also do some conceptual type videos. So if videos are your thing, check those out.
Yeah, John Wood, JONWOOD. John Wood is awesome. He has like 100 videos on ML.NET from just getting started to more advanced options. And I think we did skip the question, can I retrieve and refer a specific model at runtime? Do you want to answer that, Luis?
Yes. So yes, I want to answer it. No, you can't at the moment. Sorry, retrieve and refer, meaning that can you load it at runtime? Yes. Can you build the schema to make predictions during runtime? Not easily, but it is something that we're exploring, and we have some ideas of how we might be able to do that. So stay tuned.
Great. So yeah, to wrap this up, what's next for ML.net? What can people expect to see later down the line with it?
Yeah, so we're working on our deep learning story. We're a bit limited in our scenarios right now and what you can train like custom wise. So we want to add the ability to train neural networks from scratch. In ML.net, we are partnered with a few Microsoft research teams, specifically NNI and Flammel, to improve our AutoML performance. We're working on ML ops, which is kind of DevOps for machine learning. So, how do you easily deploy your model, keep track of the different models and data versions, and how do you integrate that back with CI/CD and do automatic retraining? Also working on model explainability and visualizations and how, model fairness, which we posted a link earlier to our last community stand-up about that. And then also just adding more advanced options and tooling. So those are some of the things we're working on. Obviously there's a lot. Machine learning is still very new, and there's a lot of things, coming out all the time about it. So just making sure that we can keep up with that and making sure that, .NET developers have everything they need within .NET and ML.NET to do machine learning.
All right. Great stuff. And one more question. So the ask is about Maui. Is there any integration with that? Or will there be any?
Maybe. So the reason why I said maybe is, I don't know if there's anybody that has actually tried it yet, but ARM support actually just, was in the latest release. So because now there's ARM support, right? Not only can you run it on M1 devices, training on M1 devices, as well as ARM devices, but you should also be able to inference on ARM devices. So it's a yes, right? I would say, but we haven't actually, tried it out with Maui doing that integration. But I suspect that if you're going from, let's say, a Xamarin type of environment and Maui sort of retains a lot of those components, then the answer should be yes.
All righty. Cool. Well, that is all the time that we have for today. But yeah, if you're interested in learning more about ML or ML.net, definitely hit up all the links that were posted in the chat and all the other links that Louise, Bree, and I discussed throughout the whole past hour and 10 minutes. And also reach out to them on Twitter. They posted their Twitter handles. If I hide this, there they are. So definitely reach out to them if you have any additional questions. And I can't wait to see how this evolves over time. Like, yep. Like I remember seeing ML.net. Yep. All the YouTube sayings. Yeah, like it's cool to see how much this library has evolved. Like I remember when it first came out publicly, like 2-3 years ago. And it's so different now from how it was then. So it's cool to see. So yeah, so thanks for being here, Louise and Bree.
Yeah, thanks for having us on. It was awesome.
Awesome. So until next time, y'all, happy coding.
Take care.